So hi, I'm Joe Littlejohn. I work at Mix Radio in Bristol, and we do our kind of main product is a personalised radio service. Formerly part of Nokia, and we're kind of part of the big bit of Nokia that got acquired by Microsoft. So we're now Microsofties. Not reflected very well in our tech stack, but you know, we're part of Microsoft. So what I'm kind of going to talk to you about today, I want to talk to you a bit about our kind of history of deployment, but that's not really the kind of focus of the talk. So we've been doing continuous delivery, or something that you might kind of call continuous delivery, quite a long time in Bristol. So what this talk really is about is kind of how our first attempt at a deployment model inspired by the ideas from continuous delivery looked, and you know what it was that we kind of built around tooling and deployment, and what the kind of second generation of our approach to continuous delivery looked like. So let's just start with a bit of history, and as I say, this is kind of not the focus of the talk, but just to set a bit of context, I'll kind of talk about where we've been in the past. So like a lot of software delivery places, we have big bang releases in our history. So maybe kind of 3 to 4 years ago, this was us, the famous scene here from Dr. Strangelove, Major Kong riding the giant atom bomb, the release of mass destruction. We had a kind of 3 to 6 month kind of release cycle, big bang releases, weeks of testing activity associated with them, UAT, weeks of UAT, performance testing, and finally we kind of felt a bit like this guy driven insane by the kind of all of those problems, which I don't need to convince you guys about them, being problems, but we were once doing releases, a bit like this, and I guess kind of the first thing that we tackled to kind of alleviate some of these things. As I say, I probably don't need to go into a lot of detail about the pains associated with big bang releases, but the architecture that we had at the time, it was a service-oriented architecture, so at a very kind of abstract level, we had a collection of what you might consider very coarse-grained services at the time. So we had this kind of notional split of front-end bits here. There might be the website and our kind of public API, a collection of services, kind of like back-end services that implementing our platform, and then some persistence things, mostly MySQL in those days. But we had a service-oriented architecture, but our model was kind of collecting together new versions of all these services and doing a big bang release of the entire platform. So obviously our first step to kind of tackling lots of these things, when I'm talking about these big bang activities, it was lots of sort of manual deployments. No, the word DevOps wasn't really in people's vocabulary. We're talking 3 to 4 years ago, and our kind of first kind of like step forward, I guess, was automation. And I'm talking here about just automating the process of deployment, so getting a service from version N to version N+1 in an environment. All of the steps associated with that, we kind of tackled that and did some automation. And this is kind of our first bit of tooling around automation. It's a Java application implemented in GWT, and this allowed us to kind of like at least deploy these services in an automated way, and orchestrate all of the steps involved in a deployment. So installing RPMs, restarting containers, doing F5 orchestration, that kind of load balancer orchestration and that kind of thing, to kind of create a release, or at least increment a service version, was automated. And so that was the first step, and just collaborating on this tooling was a great sort of boon for the organization to get a lot more collaboration between dev and ops guys, and this is kind of our big sort of first steps on that path. And then of course continuous delivery being not just about automation and taking taking services from version N to version N+1 in an automated way, but our kind of thinking moved on and started, we started being influenced by this book, obviously, and the idea of kind of code readiness started to, be a big thing for us. So not just releasing in an automated way, but having a code base that could be released at any time, released continuously. So this was this was very influential on our thinking at that time, this book, and in terms of evolving our tooling, we one of the big ideas was the pipeline, and this was a way of not just getting our services from one version to the next in one environment in a predictable and repeatable way, but the pipeline gave us a model for doing that across environments and doing releases in a repeatable way. And I guess everyone's here is probably very familiar with the concept of the pipeline, and really it's about doing complete releases in a predictable and repeatable way, and creating visualizing your deployment process as a pipeline and using that to have the whole business understand the deployment process. So inspired by the continuous delivery book, Jez and David's book, this was at the time our continuous delivery pipeline. So this was kind of our what you might think of our model for deployments. So we had a number of environments that we would move releases through. We had a kind of what you might consider like a development kind of testing environment, a staging environment which was in the live data center, kind of a replica of the live production system in the data center. Then we had our live or production environment, and a like live environment. So this is kind of in our development labs, but a good place for third parties to integrate with and things like that. An environment that was always running similar software versions to live, and was a good place for third parties to test or our clients, that kind of thing. So that was kind of our version of the pipeline, if you like, and there was a second model, a second pattern that we applied, I guess, to help us at this time, in an organisation that was still kind of getting to grips with the notion of continuous delivery and the sort of fear of making constant change to the platform of what that might mean. We applied a second pattern, and that was one of a kind of exclusive transaction around these environments. And this was really about guaranteeing consistency across all of these stages. And the rules of that exclusive transaction were that if an application entered this pipeline, that we would deploy and test and move through the pipeline, and if tests were successful and we successfully moved through these stages, we would reach the end and effectively what you might consider commit to the transaction. And obviously, if there was some testing activity that failed, then we would roll back the transaction. And this gave us, we were optimizing here for consistency of our environments. We were trying to create a process for which we could not conceive of a way in which a test early on here might not actually bear out in live because there's something else about the environment which is not quite consistent. And in terms of tooling, so this was our kind of representation of those ideas in tooling. So what we built up here is another application. It's kind of sitting above the level of our first pieces of automation. That stuff is going on in the background when we're talking about deploying a service and moving the service version from one version, moving a service from one version to the next. That tooling is used in the background, but kind of over the top of that, we have this application which is kind of applying the notion of a pipeline and applying the constraints of the pipeline, if you like, which is moving through environments in a consistent way, giving everyone visibility of what's going on. And you can imagine that, you can kind of move through the stages, move through these environments. If the service is healthy and your deployment is successful, then things go green as you're moving through here. And at any time, you can kind of say, you can pull the plug and say, no, something's gone wrong here, and we can roll back. So that was our first attempt at kind of the continuous delivery and the continuous delivery pipeline ideas. This was our implementation. So if we think about the pipeline as a metaphor for deployment and why it's useful, thinking about kind of what pipelines are and why we might use them to describe deployment. So what are the characteristics of a pipeline? Well, one of them is that its length is greater than its diameter. That's kind of what we think of a pipe. When we visualize a pipeline, it's kind of a long thing, and there's a series of steps in the pipeline. Or there's, its length is one of its defining characteristics. The other defining characteristic is the idea that it's a constrained kind of path from A to B. You put things into one end of the pipeline and they come out the other end, and it's possible to have pipelines with forks in them, but they represent constrained paths. So that fit with our model of deployment, and certainly those were the kind of characteristics that we sort of would think of our deployment as having. We'd think of that length, i.e. deploying through a number of different environments. There's lots of steps involved there. And we also kind of like the notion of applying constraints, because those constraints give us repeatability, and that repeatability gives us consistency of deployments. But there's another notion associated with the continuous delivery pipeline, kind of as described by the continuous delivery book. Here's a quote from Fowler, not from the book, but he says, a good way to introduce continuous delivery is to model your current delivery process as a deployment pipeline, then examine this for bottlenecks, opportunities for automation, and collaboration points. And another quote, this one is from the CD book. As a result of introducing the pipeline, everyone in the process gets two things: access to the things they need when they need them, visibility into the release process to improve feedback, so that bottlenecks can be identified, optimized, and removed. So, these guys have both called out the idea of identifying bottlenecks, but really what they're both talking about is using a CD pipeline to kind of visualize the process, and that giving you an opportunity to optimize it, that giving you an opportunity to cut things out, to get rid of things, to change your process. But the pipeline's there to kind of make it visible and identify those things. So if we look at our pipeline, one of the first things that we did was kind of look at this as an opportunity to say, okay, we have this kind of long pipeline of steps, and there's testing activities involved in each one of these steps. But is each one of these pulling its weight? Is it giving us enough value? Because every one of these involves maintaining this environment that has a cost associated with it. It makes the deployment time longer, so there's a cost associated with that. So we kind of saw the next step as an opportunity. Right, let's just cut, and get rid of anything that's not providing enough value. So the first thing that we did is take our pipeline as it was and cut out that staging environment. So this environment here, we cut it out. We didn't think it was providing enough value. We were getting more and more confident in the quality of our testing activities going on in our labs, and we were very happy to go based on the quality of those tests. Very happy to make the next step, pushing into production. So, that was our kind of first win. But you can see there's a bit of a pattern here, that what we're kind of doing is chipping away at this pipeline and kind of cutting bits out. So at the same time as our thoughts about tooling evolving and thoughts about delivery evolving, obviously the thoughts about our thoughts about our architecture and implementation of the platform were changing. So if we look back to, oh dear. Hopefully that's not died, but if we look back to our architecture diagram that I had earlier, so our kind of typical implementation here at the time was, we used Java, and most of our services here were implemented in, our container we used here was JBoss. There's some Apache and PHP in the front end, so to run the web and things like that. But the platform services implemented using Java and JBoss, technologies like Spring and Hibernate, those kinds of things, and mostly MySQL for persistence. But of course, the process of continuous delivery let us, I guess, deliver things more frequently, and at the same time our kind of thoughts about how best to implement our platform and how best to approach this kind of process of creating a service-oriented architecture was also evolving. And so our architecture moved from something like this to something like this, where it's getting much more chaotic. Services becoming much more fine-grained, so we're no longer using this kind of coarse-grained approach to SOA, and our implementation of these services was transformed radically. So we moved to Clojure, and we use Clojure pretty much exclusively for new work. We still have some Java in our platform, but most of our services are certainly new things that are almost all implemented in Clojure, and slowly the whole platform is implemented in that way. We use Jetty and not JBoss these days, and of course on the persistence side, as you can imagine, we've got all kinds of things, not just MySQL, we've got all kinds of things going on over there too. So we use Mongo, Redis, Zookeeper, a whole different gamut of persistence technologies that kind of fits what we need. And I mean, our notion of what a service is has changed quite a lot. So, some people might call these microservices. People have lots of different definitions of what a microservice is, but certainly in our case they are small and they're intended to do one job well. So, our architecture is evolving and changing. As you can imagine, as we're deploying services from an architecture that looks a bit more like this, the chance of two people ever working on the same service is kind of rapidly going down in this model. There are a load of benefits to kind of deploying one thing at any one time, not bunching up changes. We certainly don't want to encourage that in our tooling. And the more that our architecture is kind of fragmented, and we have more and more of these services, our exclusive deployment transaction starts to become a bit of a problem. And with an architecture like this, the result is, of course, queuing. And people begin spend more and more of their time waiting for the opportunity to deploy, and waiting for that notion, being able to get that exclusive right to deploy. And lots of the things that we're doing around the implementation of our platform is helping us move more quickly. Clojure is a language that's a lot less verbose, and we're trying to iterate more quickly, and so we're kind of beginning to feel that some of these constraints that we imposed, that were imposed for good reasons, because we were in an environment where we were trying to allay the fears of a potentially more risk-averse organisation, and the deployment transaction was one of the things that helped us do that. But this queuing was a problem, and so the next thing that we did, looking at our kind of continuous delivery pipeline model, was to reduce this exclusive transaction down.
Just a question about the queuing. Why would you have a queuing? Wouldn't you just deploy on their own servers? What's the queuing for?
So the idea of this this transaction, what makes this exclusive is that when a service enters this transaction, it's effectively got an exclusive deployment lock. In fact, early on in the process, before we kind of formalized these things in our tooling, we had this idea of what we called a build badger, and it was a physical thing. It was actually a cuddly toy, and that was our exclusive token for deployment. And it became a kind of, there are other times when it was a specific chair, so there was a specific machine that people would use for deployment, and in order to do it, they'd go and sit in the chair and use the laptop that was there to do deployments. So, of course, by introducing this transaction, what we've done is guaranteed consistency across these environments, because people, once they enter it, either they commit all the way through or they roll back, and the system's left as if they hadn't touched it, or it's moved on to the next consistent state. But as we move through this pipeline, obviously, there's testing activities associated with these environments, and that exclusivity means that if there are more people queuing up changes, then we end up with the notion of queuing. So it could take, I guess in the worst case, it could take an hour, say. That's an extreme example. It would probably be somewhere between 10 minutes and an hour.
That's to go from beginning to end?
To go from beginning to end, yeah. So,
all your testing or staging,
yeah.
Any UAT or anything?
Yeah. So
the locking was for that particular service, or was it the same host being used to deploy other services on it?
So the locking was a platform lock, if you like. So you're deploying one. You can deploy one service at a time.
Okay. So there's a tooling limitation then.
Exactly. Yeah. So yeah. The ideas that we kind of were building on in terms of how we designed our continuous delivery system, we were pretty ambitious about the time it would take us to get a change into our production system, and the more that we started to change the architecture of our services and started to kind of operate in that mode of attempting to deploy smaller changes more frequently, a deployment time kind of even 10 minutes to an hour, that kind of level of blockage in our system became a problem. So as I say, we reduced that exclusive transaction, and obviously this idea of exclusivity, of kind of blocking other people out from deployment, was not an inherent part of a CD pipeline. It was really, for us, a reaction to it was a very conservative approach to our deployments that gave us the ability to be confident in the consistency of our environments, and gave sort of other parts of the business more comfort in the idea of releasing regularly, releasing constantly, and being confident that things have remained are consistent and that our tests are valid. So the big opportunity for us really to kind of revisit our approach to deployment, revisit our approach to testing, and how we how we structure our whole, our setup of environments was moving to AWS. So the deployment process that I've described was up until not long, up until maybe a few months ago, exclusively deploying to our data center. And, for a whole load of reasons, we are moving our platform into the cloud, like a lot of people are doing. So really for us, this was a question of do we want to replicate our current model of deployment for AWS? And if not, what would we like to change? So in terms of how our thinking about what a good model for deployment would be to AWS, I'll just kind of go through a bit about our tooling. So in practice, at a slightly more fine-grained level, what does the tooling look like for AWS deployment? So we took a huge amount of inspiration from the way Netflix deployed to the cloud. A few of the kind of fundamental principles that we have adopted that have come from kind of Netflix thinking and their way of working. The first one is the idea that we bake AMIs. So our unit of deployment, if you like, for some people it might be an RPM, for some people it might be a jar or a WAR file, and when deploying to our data center, we used RPM as our unit of deployment. So the deployment process would be about taking an existing machine, stopping the service on that machine, installing a new RPM, restarting the service, and then putting that back into the load balancer. And so our deployment process was kind of one of a round robin approach to taking some existing servers and updating the software that's running on those servers. When we move to AWS, our unit of deployment has become the AMI, and the baking process is about taking a base image, if you like, which is kind of what we have agreed is a good starting point for a server, installing a load of things on there, the new software version and any of its dependencies, and effectively taking a snapshot, and that's our baked AMI. This idea of baking has come from Netflix. Another place where we take inspiration from Netflix is around how we think about our servers. So the idea of a Phoenix servers. So this is not a term that's come from Netflix. I think it's a term that's come from ThoughtWorks. But the idea here is one of we think about our servers as things that should be able to die and rise from the flames like a phoenix repeatedly, regularly, whenever necessary. So we're no longer kind of treating our hosts like another sort of analogy that people use is that we should be treating your servers like cattle rather than pets, and it just means that we bring up servers to host a service, and then when we want to make changes to that, we want to release a new service version, we throw all of those away and we create some new ones. And in response to having to scale up to accommodate more traffic, we can instantly just bring up new servers into life, and if anything's wrong with a host, it can just be thrown away, and a new one will rise like a phoenix. And the third kind of model that we take from Netflix, I guess, is one of red-black deployment. And so the deployment process here, where in our data center and applied by our original automation of tooling, we're kind of in a world where we would do round-robin upgrades of a load of servers. Taking these kind of components and then looking at the deployment process, it gives us an opportunity to have a safer process and potentially a quicker process whereby we can bring up. So we'll have a group of servers that's serving live traffic. we'll bring up a new group of servers that are running the new platform, run them together temporarily, and then kill off the old. And this is a process known as red-black deployment. So for us, how this is implemented, I'm not going to go into a lot of detail, but we implement closure services all day. So when it came to doing deployment tooling, we implemented our tooling as a load of closure services, and we use Git whenever we have versioned configuration to manage. We use Packer to build AMI images, and we use Asgard, which is a piece of Netflix tooling which gives us this red-black deployment process, and it effectively implements that red-black deployment process for us. So that's how our tooling is implemented. In terms of how we interact with it, we have an application that kind of sits outside of those services, which is a command line application implemented in Go. And this is how, in our second generation of tooling, we do all of our deployments. It's how we do a lot of our testing. And we are mostly we're kind of closure engineers. Our stack is an open source stack. We use Linux all day, every day. So the most effective tool for us is a command line tool for deployments. In terms of what that means kind of in practice for the tooling, we have our command line tool that we've implemented is called Clink. And the first thing that we need to be able to do when we deploy is obviously we need to bake. This idea of baking a new machine image. So we have a service that deals with baking, and as I said, it uses Packer to actually bake new images. You can imagine that when we want to bake a new service, we need to know what services are available. So we have an application directory, and this is a really useful thing if we want to build tooling. So if we want to build dashboards or any kind of monitoring tooling, it's really, really handy to have a service that knows what applications exist, and it knows what, it might know the source URL of those services, and it might know other details about them that are kind of just useful. And in this case, of course, we use that list of available services to know what we can bake. So we want to deploy a new service. We are going to use our Clink tool to bake a new image, and we now know which services are available to bake. What can we do with that new image? Well, obviously we can deploy it, and that's where we have an app deployment services. As I've said, we use kind of Asgard to provide that red-black deployment implementation. The next service that we have in our kind of set of deployment things is around app configuration. So you can imagine we bake an image, we come to deploy it. Well, we need some configuration. If we deploy to an environment, we're going to need to there's some app environment specific configuration that we need. So we have an application configuration service, and it's backed by Git because we don't really want to re-implement our own version control for service properties. So it stores all its data in Git, and it's versioned. But so we come to deploy to an environment, we can bake an image, we can give it to our deployment service, and that can inject some configuration and deploy. So that's kind of the heart of our automation now. There's one other service that's useful when we're thinking about cloud tooling, kind of managing what we're running in the cloud, and that's infrastructure configuration. Mainly things that don't change on a deployment to deployment basis. So things like ELBs that exist, security groups that exist. These are kind of constructs that exist in AWS that we're not going to change with every deployment, and they may not change regularly, but we certainly want those things to stay in sync if people change things within the console, and we certainly want to be able to recreate them if they're lost or if we need to spin up a new environment. So we have this service for infrastructure configuration, and You can kind of think of it a bit like Puppet, but for AWS. Similar to what AWS provide with CloudFormation, but we kind of wanted something quite a bit simpler, something with a nicer definition syntax, and we use Clojure for those definitions. So this infrastructure configuration piece is the core of it has been open sourced, and it's called Cluppet. So if you're interested, you can take a look at that. We've got hopes to open source a lot more of these deployment tools, but the first one is Cluppet. So just on the topic of us using Asgard, it was a great way for us to get our deployment tooling kind of bootstrapped. When we were new to deploying to AWS, it kind of gave us a ready-made model for that simple automation of service upgrades. But soon, we soon found it quite restrictive, and we soon found that we had our own ideas about the best way to implement those red-black deployments. And we wanted to customize the process, which is, quite difficult. We didn't really want to maintain our own forked version of Asgard. So we replaced it and just used a Clojure library, Amazonica, to implement, to interact with the AWS API directly, but still with the same red-black model for deployments. So if we kind of go right back to where we started, this was our kind of first generation of our pipeline. It certainly was, longer than its diameter. It involved many steps, many environments. Looking at this and thinking about how we should deploy to the cloud, and how we, what we felt that we needed when we moved to the cloud, we ended up with sorry. So that was our pipeline. What did we feel that were the kind of the core ideas that we wanted to maintain when we moved into AWS, and when we were thinking about what we were going to do there? One was certainly the notion of repeatability. So it was very important for our deployments, not just to a single environment, but releases, the whole activities associated with a release to be repeatable, to be consistent, and for people to know what they should be doing when they make a release. It needed to be fast, so our ideas about what a fast release meant were kind of changing all the time, and we were very keen that when we had a one-line change, how quickly could that one-line change be deployed? And if it takes an hour to get that released, then it's an hour of release ceremony that we feel can slow us down. And kind of the third characteristic that we wanted our process to be flexible. So this is potentially quite a hard thing to solve when we want repeatability. So it's possible to solve this notion of repeatability by applying constraints and locking down what your release pipeline looks like. Of course, the more constraints that you apply, it gives you that repeatability, but you lose any kind of flexibility. And any flexibility that you do introduce into the system involves potentially changing your tooling, putting in more kind of optional bits of your process into the tooling. And it's costly to do that. And part of that process of applying constraints to your deployment to make it repeatable is about removing flexibility, and we wanted to try and have a system that had all of these three characteristics, mainly because there are occasional exceptions to the kind of the deployment rules, if you like, and if we can accommodate those, then without changing and applying lots of adjustments to our tooling constantly, then that's a good thing. So how is this embodied in our kind of like second generation of deployment tooling when we go to the cloud? Well, sorry, this thing's not. So this is what we ended up with. You can see that we've only got 2 environments now. It's not looking very much like a pipeline. We've kind of hacked away bits. We've taken this inspiration of you know, examining our pipeline for bottlenecks and kind of cut it down to the point where the pipeline as a metaphor doesn't really make much sense for us. We've obviously got our production environment. Oh dear. So prod is our live production environment. Any guesses as to what this environment is called? It's called poke. So we have poke and prod, those are our 2 environments. This is effectively our testing environment, and you know, it's obvious what the production environment is. So what we've really done here is use this second generation as a kind of a way of cutting out waste. As I say, it doesn't really look very pipeline-like. We've also kind of got rid of this idea of an exclusive deployment transaction, and we've got rid of any notion of tooling orchestrating the moves through these environments. So how have we got repeatability? Well, the way that we have a repeatable deployment process is that the deployment process is very simple. And if you look at the notion that we now have of these 2 environments, you know, one way to create a repeatable process is to apply constraints, and that's what, you know, the notion of a pipeline of a constrained way of getting from A to B. The pipeline does it by applying those constraints, whereas we do it by making a release process that is so simple that it's very easy for people to follow the same path repeatedly. So kind of that simplicity and that cutting out of unnecessary steps and ceremony in the process gives us something that's repeatable without constraints. So deploying a service now, what does that mean now that we don't have this notion of a pipeline? Well, let's imagine that we're deploying a service called Heartbeat. That's just a random name for service that we might have in our system. It involves now 3 commands with our deployment tooling. First one, deploy to our poke environment. Second one, test our service. Third one, deploy to our prod environment. So alongside any automated test runs that we might be doing, we've obviously got a huge amount of monitoring of our live system. We've got alerts, we've got dashboards all over the place. So those are kind of part of the whole range of activities that we do that give us confidence in those releases, and we've moved away from this notion of a long delivery pipeline involving many steps, many quality gates, many testing activities, to the point where deployment involves 3 commands. And again, the idea that we need to now restrict this deployment process by applying this model of, okay, we're going to constrain the constrained deployments into a kind of pipeline, kind of is irrelevant to us, because we can deploy now as simply as this. So that repeatability is you know, a non-issue for us. It's embodied in our tooling through simplicity rather than constraints. So that is phase 2 of our continuous delivery. And I mentioned how we no longer have this idea of an exclusive transaction. We no longer have this idea of constrained deployments going through the pipeline. And so you can imagine now that really there are constantly engineers deploying to these two environments. Our deployment process maybe looks a bit more like a shooting gallery than a pipeline. And we are able to give ourselves confidence in the quality of our releases through a whole range of mechanisms, rather than this kind of heavyweight transaction around the deployment process. So, to sum up, what are the kind of the key headlines that we feel were the kind of most important in this transition from our first generation of tooling to our second generation of tooling? I guess the first would be a kind of applying automation judiciously. So if we, automation at the level of upgrading our service and not having to do those steps in a manual way for an instance, that level of automation is great. But when we start to automate the process and build a lot of tooling and automation around the process at a high level, what we're obviously doing there is also kind of calcifying the process and making it a lot harder to change that, making it harder to optimize. And to address some of the reasons that we want to automate, repeatability, speed, we can sometimes use simplification as a mechanism to do that too. If we cut bits of the process that don't pull their weight, we can also use that to get some of the benefits of automation without necessarily having those costs of calcification of our process. Another kind of key takeaway is that it may be useful to think about the continuous delivery pipeline as a transitional metaphor. It's a fantastic tool for visualizing your process. And there are organizations which may rely on that metaphor of a pipeline and may rely on that explicit definition of the pipeline, because there's lots of handover of steps from engineering teams to QA teams, and having a rigid pipeline in order to guarantee that consistency is required. But that might not be the case everywhere, and it wasn't the case for us. And so it is okay to use that idea of a pipeline as a transitional metaphor. Certainly use it to visualize your process, but it's an invitation to also cut bits out, to hack bits off, to optimize what you're doing. And if you end up with something that doesn't really look that much like a pipeline anymore, that's not necessarily a bad thing. And then the third one, not so specific to the notions of pipelines, but this second pattern that we applied around creating an exclusive deployment transaction was really about creating a watertight or airtight system, a system in which we could not conceive of a way in which a test that we had ran earlier in the process might not be valid later. But of course, if those kinds of failures, if there are other characteristics of your system that make those kinds of failures rare, then maybe it's a good opportunity to optimize your system for something else. So we've started to move away from optimizing our system for the kind of testing approach that you might be happy deploying to the space shuttle with, and relax some of those constraints, because pragmatically those risks could be mitigated in other ways. And that's the end of my talk. So thank you.